We're going to be talking about biosecurity, the unseen threats to your hatchery, because it's kind of come into the forefront of our minds at the moment. So we're especially in North America, Canada, where avian influenza has popped up all of a sudden, but I know from past experience, when you're running a hatchery, you got a lot of other things going on in that mind. So particularly chicks out the door. And sometimes you sort of that thing of chicks out the door becomes more important, and biosecurity gets pushed a little bit to the back of the mind. And we want to use this opportunity to bring it back to the forefront and give you a few thoughts on biosecurity. So we're going to look at what is biosecurity first of all. We will look at enemies at the gate. It will become clear as we go along. We'll look at the kinds of transmission. The usual suspects. So the usual suspects are those pathogens that we typically see in the hatchery, that the key ones that give us the biggest problems. We'll look at what is a vector and why that's important, how we're going to control those. And we'll look at the 5 golden rules for your staff. So very simple, but if they're doing that, then chances are we'll most likely be okay. We'll also look at managing visitors. So that not just people, but unwanted visitors as well. And then we'll finish off with cleaning up. And in this case, I'll be talking about a hatcher, but to be honest, it could be a hatcher or a room. The principles are the same. So first of all, what is biosecurity? Well, it comes from Greek and Latin, like most of the language we use. And it's just basically keeping life safe, particularly from anything that wants to destroy it. In this case, we're talking about pathogens, so diseases, fungi, bacteria. Now, if you look at this, your operation will be that castle at the back there. All your enemies are at the front trying to get in. And like Terminator, these things, they never sleep, they never back off. Because they don't take a day off, we can't either. So the moment we start to relax our biosecurity, these things are going to be coming through. And it only takes one break to really destroy your operation. So you'll be short of product. It's very difficult. So we need to keep this in our forefront of our minds. If we look at, if we break down the pathogens to 4 basic sectors, and the ones we're going to talk about today is more viruses, bacteria, and fungi. Parasitic animals are more of a farm issue, so we're not going to be looking at those today. If we can break that down to 4, then if we look at all the problems that we might have in a poultry production, you'll see it's quite it's huge, and obviously we can't cover all those, which is why we went with the usual suspects, and we'll pick the key ones that we have problems with. Let's look at the vectors. So if we look at vectoring, the first one is vertical transmission. So transmission. We look at vertical transmission, so that's where it's picked up by the mother hen. So if she's got a bacteria inside it, we picked up inside the oviduct. So by the time the egg is laid, it's already infected. So true vertical transmission means it's coming through inside the oviduct. Apparent vertical transmission means it's on the surface of the egg. In terms of how that affects your operation, it's exactly the same. The concerning thing is that it's going to be coming in. It's going to be coming in to your operation. So if we're looking at a Microplasma, for example, it can come in on the surface of the egg. It can come on the inside. Key thing is there's nothing you can do about that. So it's not like you can clean it up. Let's look at horizontal transmission. So that's quite more exhaustive, to be honest. Let's say you have an operation, a disease truck drives past your operation. Any bacteria can be carried on the wind and passed around onto your farm. So it can be airborne, it can be brought in by rodents, frogs, lizards. Here we have a big problem with lizards. pretty much anything. The birds is a key one, which we'll also cover today. Beetles, ourselves. So particularly when we go from one house to another, the tools that we bring into that operation, it's quite easy to spread disease by this, by the equipment we bring in. What it's looking at now is inside a drinker line. You'll see that biofilm that starts to build up. Also from other birds, so if you was to do spiking as an example, you can actually bring disease into your farm that way. Or even from in the hatcher, if you've got the disease that as an infection, it can spread that on to other flocks that are inside the same hatcher. And particularly if you look at the equipment, so in terms of in the hatcher, your carousels, your conveyor belts, if you've got a diseased flock going through first, and then you've got a clean flock going through the second, that clean flock is going to become infected. So let's look at the usuals. So this is the key ones that give us, or the ones we have to be most aware of. And if we can keep these out, then we can generally keep most of the other ones out. First one is Microplasma. So if we look at Microplasma, because it has no cell wall, it can't be killed by penicillin type antibiotics. The two, if we look at Microplasma synovi, so that can affect pretty much anything in the bird. Microplasma gallisepticum is going to be more respiratory. The problem with the Mycoplasma is that energy, the bird is going to be trying to fight that infection, so the performance will drop. The other thing is because that the immunity will go down, it's very likely to pick up a secondary infection. So things like pericarditis will start to creep up. So you'll see a lot of other problems when actually the root of that problem can be a Mycoplasma. Of course, because they're vertically, horizontally transmitted, everything has to be slaughtered. If we look at survival times of Mycoplasma, so here we've got shavings for 8 hours, wood 1 day, straw 2 days. Key one here is feathers, because it can sit on the feathers for 4 days. So if you're receiving eggs into your hatchery with these feathers stuck on, and that flock has Mycoplasma, you've got it in your hatchery. So it's really something that we shouldn't be using. Not only that, but if you've got feathers coming into the hatchery, it's going to get stuck into the transfer head. So we don't want to bring in those in anyway. Let's look at also, if we look at just the hair and the cotton there, which is the reason why we shower in, we change our clothes, so we put in company clothing while we're there, because that then takes it into our hands and our control. Salmonella, so although there's a lot of serotypes for Salmonella, the two ones for the birds, Pilarum and Gallinarum, and those can be, unless they're acute, the infection can be, you barely notice it, but they can become quite acute quite quickly. The two we need to really worry about, because it can be transmitted to us, is Enteriditis and Typhimurium. Again, if they have these salmonellas, they would have to be slaughtered, and because it's vertically and horizontally transmitted. Then we come on to the beast of today, so the avian influenza. Obviously, we need to slaughter it, but it's not that easy. A lot of strains, a lot of different strains, but the ones you really need to be on the lookout for is H5 and H7. Because they can go from low pathogenic to high pathogenic. And they can also then jump across to other species. So pigs and humans can also pick up avian influenza. If you've got low pathogenic avian influenza, mortality can be quite low. So you might not even notice it that much. But if it flips to high pathogenic, it can wipe out the whole house very quickly. Of course, we have to slaughter everything. But the big risk here is for the people who have to do that. It's because it can be transmitted onto humans, it's really not an easy cleaning up process. It's really quite difficult to do that. Now, this is data actually from Declan Butler. So he was a reporter for nature.com. And when this first started, he was logging every break of avian influenza. So I've actually been using this for some years now, but it's still interesting the way it's shifted across the world. Now, this only goes up to about 2006, I believe. Prove me wrong, 2007, okay. Now, the key thing is at this point, when we were looking at the human cases and how many dead, you see the number is quite high. But if you look at recent years, you'll see that has really come down. So there's been a lot of work here. So it's not all bad news, it's not all negative, but it's something that we have to be really careful of. If we come more up to date, so this was last year's data. And you'll see at this point, it's not in the US, not in Canada. If we look at this year, you'll see it's made that leap across. So now it's knocking at your door if you're over there. And if you point your phone at the screen now onto this little QR code here, this will take you to Google Maps, which will give you the latest breaks. So you can actually go down to your hatchery and see if you're in that region. But what I would say is bear in mind that these breaks that are reported are only the ones that are reported. It doesn't mean to say it's not there. So you have to assume if you're anywhere within these countries that it could be knocking at your door right now. So we have to take those precautions proactively. Don't wait until there's a reported case. If we look at Aspergillus, so Aspergillus is a fungus. It's found quite prolifically, actually, in hedgerows and that kind of thing. But when it comes into your hatchery, it's going to come in probably from the litter. So it will be transmitted from the feet of the birds into the nest boxes. So nest box hygiene is important. And so it will actually come in on the surface of the eggs, or it will come in through the HVAC. And if you look here, for example, although this looks very pretty, if you're drawing air in here, any Aspergillus produced here is going to just be brought into your HVAC. So you're going to be constantly fighting it. Now, because it's a fungus, it likes warm, moist places, and the lungs of the bird are perfect for that. That will go down and actually start reproducing inside the lungs of the bird. And I've had aspergillosis, and it's not a very nice feeling. So and it's not that easy to get rid of either. So you're going to need to use something like these with I can never say this properly, N-conazole active ingredient. Both those products work very well, but any product that's using that will get rid of the Aspergillus. But you have to be careful when you're using it. Give you an example here, though. So this is actually from the transfers module that I do, and if you're transferring and you're removing your bangers and your rots and putting them either into a dry bucket or, like in this case, on a keys tray, bear in mind those spores, when they break, they're going to go into the atmosphere. So if you're doing a transfer here, for example, and especially if you use or you've got ductwork on the inside of your building, so normally you should have a false ceiling here, but it will go up there, replicate, and start dropping back down again. So you'll have a constant Aspergillus problem. Of course, much better nowadays if you're going to put a false ceiling in. It might be a bit tricky here because the ceiling is quite low if you do that. But you need to make sure that your hatchery is easy as possible to clean. So, for example, if you've got curbs, coving, your drains, make sure that you've got no 90-degree angles because dirt can hide in there. So make sure it's always easy to clean. Drains, you want to use a slot drain, something like this, because the water will run away quickly. And another, actually, a customer of ours was, so this is actually an old potassium permanganate drum, which they're repurposing. Put a hole in the top of it, half fill it with disinfectant. So when you drop the banger or the rot through, if it breaks, it's then caught by the disinfectant. So it's not going to go on to contaminate the rest of your hatchery. Now, Aspergillus, I always liken it to if you go fishing and you go out and your boat springs a leak, is what do you do? So are you going to start bailing out the water, or are you actually going to plug the hole? And Aspergillus is kind of like this, because what I see a lot of people will start bailing out the water, forgetting that you've got to actually plug the hole as well. So unless you're going to need to clean up your hatchery, of course, but you need to stop it at source. So it's no good cleaning up your hatchery, then bringing more Aspergillus in from outside. So we need to make sure we do that. That's relevant for a lot of other things as well, but Aspergillus particularly, I find that. Pseudomonas. So again, Pseudomonas is quite a common bacteria, but it can become quite prolific. And when that's the case, you'll find that you'll start finding it in your birds. You'll have quite a few problems with that. So you'll find it in drinker lines, in thaw baths, in humidifiers, especially if you've got the old disc spinning humidifiers, especially in the hatches, because you've got a lot of chick fluff that will sit in there. And you'll quite often find the Pseudomonas will be sitting in there in that bath. Couple of examples of, so the top bird there was actually injected with vaccine. That was thawed in a thaw bath that had Pseudomonas in it. And what happens is when you break the tip off the vial of vaccine, if you get a little drop of water go into that vaccine, you've then contaminated it. And this is exactly what happened here. The other one is just on the foot, but just shows you what Pseudomonas can do. So we'll look at vectors, and vectors are just a means of transport, essentially. So it's the easiest way to think of it. If we look, well, we think of mechanical transport. Of course, there's also biological transport. And that's where, if we're looking at pathogens, where most of them come in. And the mosquito is a good example of that. So I live in Malaysia, where we have dengue fever, malaria, and so we're very aware of this vector of the mosquito. And what we need to think about in our hatchery operations is what else is coming in. So how are we going to bring these, how these diseases trying to get into our operation? So first of all, let's look at those 5 golden rules. I use the Walking Dead as a metaphor for biosecurity, because everything outside your operation is diseased. If it isn't, then we assume it is, because that's the only safe way we can continue. So how are we going to keep that out from our operation? Kind of easy. We just follow these rules. So these are for your staff, particularly. So first of all, staff should not come into contact with backyard or free-range chicken. In terms of disease biosecurity, I don't see any difference between a backyard chicken or a free-range chicken. If they're outside coming into contact with wild birds, then they're a risk. So we assume that they're going to bring disease in. Number 2, and it's more relevant if you're in Asia here, but avoid wet markets. Very popular here, but these places are going to be full of salmonellas for sure. So we don't want to do that. Don't want our staff going down there, then coming into the hatchery the next day. Number 3, that staff should not be working with other avian species. So the lady here is actually clearing runways with a hawk. And quite often you'll see broiler hatcheries, the staff will then work at the weekend collecting layer eggs. So we really don't want to do that. The fourth one, which is really quite unpopular, no wild bird hunting at all. We should not be wild bird hunting because for sure these will have salmonellas, microplasmas, possibly avian influenza. So if you're out there at the weekend hunting birds like this, you then get back in your truck, you drive to the hatchery the next day, you get out, it's on the soles of your feet, you've walked it now straight into the hatchery. So we really should not allow this to go on with our staff. Next, nobody should be allowed to own any avian species, no matter who they are. So it doesn't matter what they think they can do, they cannot own avian species because they will pick up an exotic and chances are they're going to bring it into the hatchery. So who can visit the hatchery? And I guess the question really is who absolutely needs to visit. It's not, it shouldn't be somewhere where people go and hang out. It's only people that need to go there should be allowed in. So assume that everybody is going to bring you problems. So unless they really need to be there, keep them out. In terms of your hatchery, you're going to have your hatchery there. You're going to need to fence that off. We don't want people turning up. I've seen hatcheries where people have turned up asking for directions. We should have good signposts. This one is, just be honest, it's too technical. Nobody's going to read that. So we were going to change that one. This one is a little bit too Walking Dead. So we're not going to use this one either. And probably the best one that I've seen is actually from an operation in South Africa. And it was succinct and to the point. But basically, you've got biosecurity restrictions in place. Nobody should be coming onto your site. In terms of before they come in, so here in Asia, we'll have a lot of these security booths, but you can replace these with a camera and a sort of intercom inside the hatchery. And that means that unless people really need to come in, we can keep them out. That's much easier. In terms of when people do come in, so if you've got an external visitor coming into your operation, they should fill out the visitor's book. And that's going to contain certain number of things. First one is this reason for visit. Why is that important? Because of that rule that says unless you need to be there, you're not coming in. So if you've got a valid reason to be there, then that's fine. But you need to state what that is. The next one will be the last avian site visited and the date of that last site. And that's because of the survival times for Microplasma. So in the event of there is a break, it means we can trace back where people have been. So we can work out the cause of where this has come from. But also if they've been to a site and it was only 2 days ago, we'll say, sorry, you can't come in. So we need to be vigilant on that one. The other one is a good health declaration. So no diarrhea or sickness because they're typical salmonella symptoms. And the last one on here would be that little caveat there that by signing the document that they agreed to comply with all the biosecurity protocol of the company. That means if they don't know what it is, they need to ask you. What we want to avoid is somebody coming to fix your HVAC and then walking around your chick room. There was actually went to a hatchery in New Zealand, and on arrival, the hatchery manager sat us down and he gave us a full biosecurity debrief. You can't go here. You can only go here and here. And it was really good. I mean, it was great to see that people are picking this up. So I know the message is getting through. Now, if we come back to this picture, which I showed at the beginning, now I want to talk about these entry barriers. And this is this little bit here, because of course these enemy are going to try and get through this area first. And this is what we always refer to as a killing room in a castle. And in the killing room, you'll have moutier, which is these little arrow slits. This is actually Bodiam Castle. This is where this picture is taken. And what would happen is when you get a visitor arrive, both doors would shut, and then your archers could pick these people off at their will. Of course, we're not talking about killing people. All we want to do is kill those pathogens. So when we talk about entry barriers, we're trying to stop that what's coming in or everything that's outside is classed as dirty. Once it's inside, it should be clean. So the first one is the barrier shower. So barrier shower is an inline shower. You will see that there is so this area at this point is classed as dirty, right up to this here, but anything past here will be clean. Also notice that the cubicles where you put the clothes in, they'll have a 45-degree angle. It stops people from putting stuff on top. Also easy to see that it's clean. So when the worker arrives, put their clothes into the cubicle, they will shower through. Now that is a clean area because they've cleaned it. Put on company clothing and into the hatchery. So it's all good. So this differs a little bit from a closet shower. And just show you the difference here. So this is what you'll often see in hatcheries. The problem with this is the infected area, essentially. So you'll see that this has a potential to be contaminated, which means you're going to get cross-contamination when they come back out. So this one, you won't get that. So you really want that inline barrier shower, much better. So that's the first entry barrier. Then if we look at what's going on with the eggs that come in as well, because we've got people coming in and we've got eggs coming in. And we have a dirty area and then we will have a clean area. And there should always be that black and white. You know, we don't want the gray area. That's where we need to avoid this. So anything coming through is fumigated and then into your egg store. You might need to change this depending on your operation. So if you have eggs coming in on 30 size trays and then you have to unpack them, then you will have to have this would also be a dirty area. So you'd unpack your eggs and then you need to fumigate. You can't fumigate on 30 size trays. Just give you an example. So this is just 19,200 eggs. So the equivalent of a very small incubator, but each of these eggs has to get gas around it. So if you're going to fumigate it, every surface of that egg, as far as possible, should come into contact with that fumigant. Now, you're not going to do that if this is your egg store and you're trying to get gas around these eggs, for example. Not going to work. Not going to work here. So you'd need to unpack them, put them onto setter flats, into the trolleys, and then you can fumigate them. In terms of a fumigation chamber, it can be any shape you want. It doesn't really matter. Obviously, square or rectangle is ideal because of airflow. We would have air coming in from, if you have it coming in from the top, then you want it leaving at the bottom. We would need air circulation, but ceiling fans don't really do it. They don't push enough air where we want the air. So you're much better with wall fans. And that really pushes, you put a few wall fans around, and you'll get a nice little cyclone effect inside that fumigation chamber. It will mix the gas in and push it all the way through the surfaces of the eggs. Now, if you turn those circulation fans off when you exhaust, that air is just going to short circuit straight through to the exhaust point. So we need to make sure that those circulation fans run for the whole duration of that fumigation cycle. That means that it's going to clear that, so when you go in, you shouldn't smell that fumigant. Also remember where you draw your air from, your clean air. For example, this is actually a dirty area, obviously, because it's on the outside. People are storing this stuff here. and then you're taking air from here to purge your fumigation room. So not very good decision, this one. Another thing is you can't fumigate dirt. So if you've got material matter on that, it's going to have bacteria in it and on the surface of it. When you fumigate, you will kill the bacteria on the surface of that dirt, but you're not going to kill it that's inside. And so if it's there, it's going to penetrate that egg and going to result in those bangers that we see. The problem is, if you get into an operation that routinely washes eggs, what you will find is that washing will remove the cuticle. So here you have the cuticle of the egg, the sort of waxy-like surface. The moment you start washing eggs, this is removed. And it might look nice when it comes into the hatchery, but the damage is already done. We're going to get a lot more bangers as soon as you start washing eggs. If you have dirt on them and you wipe them, all you're going to do is push all that dirt down into the pores. So you're actually doing the job for the bacteria. You're going to make it even worse. And the other thing would be is if you scrape eggs, with sandpaper or wire wool, you're actually going to remove that whole layer. So you'll be down now to the palisade layer. So again, you're decreasing the ability of that egg to actually function. You're also clogging up those pores, so you're going to make it quite difficult for the embryo later on. Something we see a lot of now, bringing in, because we're always taking in a lot of kit into hatcheries, and these UV sanitizers. So it should be UVC. Quite important that that's the case. We'll often find these UV sanitizers at the point when we come into the hatchery. So this is the hatchery in Australia, and you'll see there, quite a nice system. It put your equipment in there, you leave it for a period of time, you go through, shower through, by the time you get round, your equipment, the surfaces are sanitized. And I've actually bought, haven't tested it yet, but I don't know if you can see that on my camera, but a little portable one. So we're going to try that and see how effective that is when we get back to the hotel rooms. That we clean our kit before we leave, but then we'll do an extra sanitization in the hotel rooms as well before we leave again. But we'll see how that works. Now, the idea of this is you put your equipment in there. A lot of the times when we go to operations, they will put your whole bag in there, just to say license. The problem is if you put your whole bag in, you're only going to sanitize the surface of that bag. You're not sanitizing what's inside it. So we need to get our equipment out and clean it before we take it into the operation. Yeah, just a point on washing hands. So these are the most missed points of washing hands. And it's really quite important. I think it's been brought quite nicely with the COVID. A lot of discussions on how to wash hands properly. So it should be for 20 seconds. You need to get right in there. There's an awful lot of bacteria sitting underneath your fingernails, enough to scare the life out of you. Another thing I would say is, and I see this a lot when they're mixing or reconstituting vaccine, people will put on a pair of gloves, and even if they're sterile gloves, the moment you start touching surfaces, they're no longer sterile. So if you're going to then go back to mixing vaccine, you still need to wash your hands. So just bear that one in mind. There's a lot of options now. There's a lot of free posters that you can get online, how to wash hands properly. I know it sounds a little bit patronizing, but sometimes we often forget how to do it properly. And in terms of washing your hands, there's plenty of things with sensors now. In the old days, it used to be your knee or your elbow, but now you can wash it with the sensors, so we don't have to go back and touch any surface. In terms of drying your hands, I've seen all of these in hatcheries. This is probably the worst. It's going to just be like bacteria laden cloth. And then this one is also no good. The reason being that you only use about 50% of it, because whenever you go to one of these roller towels, you're going to pull it twice, make sure that you've got a clean piece. You normally dry your hands, then pull it twice again for the next person, who then comes and pulls it twice. So you only use half of what's there before it's taken away. And it's just not very efficient. Then you have the standard hair dryers, which are or hand dryers, which again, we all know they're useless. Whenever you use the restroom while you're out, you will wash your hands, you'll go to dry it. After a couple of seconds, you'll just give up and wipe it on your butt, on the side of your trousers. And then the paper towel, which works so long as you're keeping that in a clean environment, and the air blade, which also work. And then we would want those hand washing facilities in each of these areas. So you see up here in the egg store, somewhere where you've got your setters, definitely in your transfer room, we need good hand washing facilities, not just a tap and a hose. We need to be able to let people wash their hands thoroughly. And of course, anywhere with the chicks, and reconstitution rooms, canteens, etc. Every door in the hatchery should have a hand sanitizer. It's one of those things when I was doing quality assurance, every time I saw one of those, I would press it, and just to make sure that they're still working. In terms of clothing in the hatchery, always better to keep your egg side and your chick side separate. So we would have one color for your eggs, one color for your chicks. And that way, if somebody's in the wrong position or wrong location in the hatchery, you'll see them pretty quickly and you'll be able to identify it. So it makes it very difficult for people to get away with it. Another thing that is nice to do if you've got the possibility is also have your drivers wearing a particular color, so that, for example, if they're going to collect eggs, they would have one color. If they're taking chicks out for delivery, they'll have another color. It means we know exactly where those people should be at any one time. If they're in the wrong place, that it will be picked up. Let's look at some other visitors, ones we don't really want. These little fellas. So if we look at rodent, the biggest threat from a rodent is from the air. So they're always very aware of making sure that they're under cover. They need to be hidden. So places like here are ideal. So rodent would run around here all day quite happily, wouldn't be seen from the air. So we get away with it. So anything left up against the side of the hatchery or the farms, this is going to be a typical place where the rodent's going to head to, stop, and then run off again. So it's always good to have at least 2 meters from the side, whether it's a farm or a hatchery, at least 2 meters of concrete all the way around. More is better, but at least 2 meters. And that way the rodent is not going to want to run across that in the first place. Also, if we look down the side of the building, we want to put some bait stations down there. So typically every 15 meters. Here, just an example. Somebody's thought about the run that the rodent would do. Now, what he would do is run in here, hide in here. When he's in there, he'll smell the bait and go for the bait. Depending on what bait you use, there's a lot of options. My preference, if you're going to use something, would be this. Reason being, when I was looking at this quite in depth, if you've got a little bit of activity, very small amount of activity, it's quite easy to see if they've nibbled on these blocks. So it's quite apparent. But if you've got only a little bit of activity here, it's hard to tell. It's not so clear. So these tend to work better. Also remember that a mouse can get anywhere through where you can shove a pen. So they're very soft boned, they will pile through, and it's very difficult to keep them out. So we need to keep going around and checking, make sure that they're not coming in anywhere. Of course, there's also birds. So anywhere, if you look at your loading bay, for example, loading bays will quite often see birds nesting in there. course, if they've got Microplasma and they defecate outside the nest, which they always do, your driver walks across that into the back of the truck. Next thing, you've got it in the back of your truck. Something that I would often do when I arrive at a site would be stand outside the site for a while just watching. And actually what I'm watching for is birds and their activity around it. So they'll often lead you to where waste is coming out, for example. So they'll be buzzing around that to go and feed. But you get certain cues from the birds, and then you kind of watch where they're going back to, and that tells you an awful lot. So this was actually one of those times, sitting outside. So this is actually now on top of the setters. Setters were just a little bit over to the rear. But this means that anybody going up here to service any of the plant or the equipment means they've got to walk through all of this. And it's very difficult now to clean this up. So it's important that if you've got any open ventilation plants, like pipes like this, we need to mesh those off, stop those wild birds from coming in. Something else, most people, when they're looking for wild bird activity, they're going to be looking up. I'm slightly different to that because I would be looking down. What I'm interested in is actually where that poop drops, so that any that excrement, you will see it on the ground below. So when you look there, you know that birds are nesting up the top. And although it's quite difficult to see here, there's definitely signs here that you've got nests, and you can see a little bit of nest there actually, and a little bit here. So don't just always be looking up for it. Have a look around the perimeter, and if you see signs like that, you know that you're going to have a problem. This is actually a truck wash, and if you look at how many nests and how many birds were in here, in this case it was much safer to take the trucks around the truck wash than through there. So if you have, depending on the country you're in, of course, but if you're in a warmer country like here, you're much better off with this kind of boom spray mechanism. But if you're in a country that gets cold, again, these are going to freeze up, so they're not going to be very useful. Now, bringing it back to visitors, but very small ones. So this was an interesting one. This was a customer who was seeing between 20 to 50% mortality. And that mortality started around day 2, day 3. It was quite tricky to actually get this down. But if you look here, you've got airflow going through here, across here, and out there. And this is where they're vaccinating, which in itself isn't a big problem until you see this. So they are making a hole in the diluent bag. And this is because the diluent bag wasn't folding up properly, so it was restricting the vaccine coming out. So this is just to show what happens when you put a hole in that diluent bag. All those bacteria and those pathogens that are sitting in the air on the chick fluff gets brought through that hole into the vaccine, so that the first part or the majority of that vaccine isn't going to be contaminated. But the more you use it, the more contaminated it gets. And then you inject it directly into the bird. So when those birds left the hatchery, actually, they looked pretty good. They were not a problem. But 2 days later, a lot of them are dying off. So if you need to use something, then you need to use a filtered air spike. You should not be putting holes into here. Make sure we use a spike instead. Now, just so we know, we're going to start talking about the cleaning of the operation. And first of all, I'd like to explain the Sinner Circle, because I'm still quite surprised. Not everybody knows about the Sinner Circle, but it's when you take cleaning, you can split it into 4 sectors. So you've got time, the mechanical energy, the cleaning agent, the detergent or whatever you're going to use, and the temperature. And by changing the amounts of these, you can increase or decrease the amounts of the others. So for example, if I increase the amount of mechanical energy, so if I scrub harder, if I put the higher pressure washer, I can reduce the others. Same as if I increase the temperature, I can decrease the amount of detergent that I use. If I increase the cleaning agent, I can decrease the others, but I have to be careful because it's going to become quite dangerous for the equipment. And of course, the cheapest one is actually time. So if I increase the amount of time, the amount of contact time, then I can reduce what I need of the others. And that's why we often use foam as a detergent, for example, because it can hold up there for much longer. So I'm just going to cover now how we're going to clean, and I'm going to use a hatcher as an example, but it would be the same pretty much, whether it's a room or whatever it is. But there's certain things we need to adhere to. So first of all, we're going to get our PPE and we're going to get our tools, cleaning equipment, so that we have them all there and we don't have to keep running through the hatchery. We're then going to open up, we're going to remove anything that needs to be removed, clean the filters, for example, cover any sensors that need to be covered before we start. Then we're going to do that dry clean. So we're going to remove the majority of that organic matter. And if there's any dried on, whether it's egg or whatever, we're going to get the majority of it off, and then we're going to get rid of that dry matter first. Then we're going to come in and put down the detergent. And detergent needs 20 minutes for those molecules to get around the dirt and lift it from the surface that it's on. And once that's achieved, we can then come in and rinse. And so now we have a machine that's almost clean. We're going to need to dry that. Very important that we dry it. So if we don't allow it to dry off properly, if we've got 1 millimeter of water on there, so 1 millimeter of water on a square meter is the same as 1 liter of water. So if we don't allow it to dry off, we're going to be over diluting our detergent that we're going to use, disinfectant that we're going to use, sorry. Also, there's going to be little microscopic pits in the surface of everything. So if they've still got water in them, that bacteria that sits underneath is not going to be affected by disinfectant. So by allowing those pits to dry out, now the disinfectant can get in there and kill everything. Right, so now we've got a completely dry machine, so now we can disinfect. So we're going to go through there, spray it all with disinfectant. And of course, once this is done, we're almost there, but we're going to need to dry that off as well, because obviously we don't want to be transferring into a humid machine. Let's look a little bit at hygiene monitoring, just very quickly. What I would say when you do your hygiene monitoring, if your results are always fantastic, really go and check what you're doing. What I mean is that a hatchery is not going to be a sterile operation. So if you always see your results are perfect, that would set alarm bells ringing in my mind. Especially with any livestock operation, you're going to see certain peaks and troughs where on certain days it will be dirtier than others. If you're seeing every now and again you get a bad result, take some confidence at least in your results. At least it means you're getting a true result rather than if everything's perfect all the time. The other thing I would say about it, and because I say this because I've seen it a few times, when you are monitoring different hatcheries, for example, make sure everybody's doing it in the same way. You might be taking a sample or the swab on 10 square centimeters, But if Hatchery B is doing it in a slightly different way, he's going to get a different result. So then you can't compare Hatchery A and Hatchery B. So just make sure everybody's doing exactly the same thing. Let's come back to as hatchery managers. What I would say is every 4 weeks, if you can, I mean, you have to. It's not a request. You have to do it. Every 4 weeks, forget everything else. Just take the time to walk around the hatchery along the outside, and particularly any of the entry points into the hatchery. So what we're looking for is there any things that have lapsed? Is there any birds' nests appearing? Is there, how's that entry in? How's the fumigation room operating? And also build that culture of biosecurity. So make sure your staff are aware of what they should be doing. And if they see something wrong, get them to tell you. It's not that big a deal. It's better that we know we can work on it rather than be unaware. And then something like avian influenza, which will not only be devastating to your operation, we've seen it actually in a couple of countries where an operation has had avian influenza and it's completely lost the confidence of the consumer. So later on, those companies were sold at a very cheap price as well. So we want to avoid that. We don't want to be in that situation at all. So just going to finish off here. Of course, remember we've got that wall. We want to make sure that everything on the outside stays on the outside, but just bear in mind that they will always be trying to come back in and get across. So although sometimes we get a little bit confident because we see that wall, bearing in mind they're not going to wait for us to let them in. So we're going to. So thank you for watching, and if there's any questions, comments, then we will go with that.
Thank you, Jason. Thank you very much. Yeah, you always prepare great presentations. I always like listening to your presentations, and I'm sure Avian's glad to have you as a consultant. You've been with them now for a little bit, and good to have you visit with us today on that. So I've got a couple questions relation to hatching egg sanitation. What about the UV sanitizers for hatching egg sanitation? What are your thoughts on that?
Well, if you're doing UV on hatching eggs, bear in mind, it's only going to affect the surface that it sees. So it should be effective so long as those eggs are relatively clean. So it's the same with anything. What we need to do with those eggs coming in is take care of them from the very offset. So clean nest boxes. Remember, even a clean nest egg is going to have 300 to 500 bacteria on the surface. And that's going to replicate every 15 minutes. So if we can just keep those levels down, so if they're clean in the first place, UV will be fine. But if they come in soiled, then UV is not going to be very effective.
So it's not the way to clean your eggs. You should have clean eggs coming in, and then that can help once they get
it would certainly be a benefit if you've got clean eggs coming in, because all you're trying to do is you've got that low level, but it's going to start increasing, right? So it's good. All we need to then do is just keep bringing it down, which is why we fumigate on the farm, and then we'll fumigate on arrival at the hatchery.
One of the things I like that you talked about in your presentation, you drew that out, dirty areas and clean areas. And I always like to tell people when they're doing sanitation, envision where your clean area is supposed to be, and then what goes in and out. Because if you're doing something in one part of that clean area, it needs to be everywhere. You can't have holes other places where people come and go on going through that. It's just envisioning what you're trying to accomplish and how you're doing it. So what disinfectant would you recommend for Asper in a hatchery? Is it something that we dealt with again just not too long ago? Hatchery's got a lot of Asper. What are your thoughts on that?
Yeah, well, in that case, I would use something like Clinifarm. But that is with Asper, it's trying to stop that coming in the first place. That's And all the times I've seen that where it's been a problem is they haven't really addressed it coming in. So whether it's in, like, especially if it's in your HVAC, it's quite tricky to get rid of because
Yeah.
obviously it's difficult to get in there properly. So you need to use that gas, that smoke to do on that. But if it's coming in on your eggs, then of course you need to deal with it there. And so it's that sort of it's one thing we need to clean the operation, but we really need to work out where the hell is it coming from and stop it at source.
Yeah. So other than if you couldn't, other than Clinifarm, your best bet is just prevent it. I mean, if you're trying to treat
prevention is much better, but yeah, of
if
course,
you're
there's
trying
always going to be time.
if you're trying to treat it without Clinifarm, is there anything else that you might think might work with that, or
anything with that active ingredient of I can never say the name right, enconazole, is it? Anything with that in should kill it.
okay? So that's the active ingredient that's working with that.
Yeah. But there's I think there's about 3 different things on the market now. It's been a while since I've had that issue.
Yeah, we see that. We see it, and most of the time they find it's in their HV system, it's in their ductwork and all that.
Yeah.
So as far as the UV lights, if somebody was to use a UV light treatment, and going to go back to that, how long of a application would you recommend? I mean,
well, it depends on how powerful the lamp is, right? So yeah, this one is supposed to be fairly quick. It's got a little timer on the top there. Can't remember how long it was, but it's much quicker than. So normally I'm used to sort of 10 minutes in there, which is nothing like this does. Something like 60 seconds. But if you're doing it on eggs, then you're going to have those eggs are going to be moving through, right? So it depends on how powerful are those UV lamps in the first place, and those lamps wear out as well. It's not like LED lighting that lasts kind of forever. Those things only have a certain lifespan, so you need to replace them.
So what disinfectants would you recommend for during the incubation of hatching eggs? I mean, is there any disinfectants like for your machines or the eggs themselves if you're fumigating?
Yeah, well, I mean, I'm still, I know it's sort of frowned upon, but with formaldehyde, I'm still a fan of formaldehyde. I think if it's done correctly, and you're really monitoring what's going on I mean, the key thing for me with fumigating of hatching eggs is actually testing that it's effective.
Right.
So I've been to a lot of hatcheries where you say, okay, how are you testing this procedure? And they go, well, we've never tested it. Okay, so how do we know it's working?
Yeah.
Because a lot of the times you'll find little spaces in the room that aren't getting any gas, that aren't so completely ineffective.
Right.
I've even been to one fumigation room that had no air inlet. So when it exhausted, there was nowhere for the air to come from. So it just created this suction inside the room. So it's we just cracked the door, but that's not really how we meant to be doing things.
So quality control after the fact is the best way to find out. So if you're going to, and that goes with anything, if you're going to implement something, test it frequently afterwards to make sure that it's doing what you think it's doing. I mean, really.
And it's very easy to do, so it's just a matter of rolling those eggs across agar plates, one before, one after, and you just see.
What are your thoughts on ozone, using ozone for disinfecting?
I've never used it, but it's an interesting one. I'm not sure about the cost, because I think in my mind it's expensive, but I'm not sure if that's true or not. But I've never had the opportunity to use it, which is interesting. My thing is always, if you're really trying to, okay, I need to clean my eggs up. Question is, why do I really need to clean my eggs up? And normally that's because your house isn't set up right. You've got a lot more floor eggs than you should have. Your ventilation isn't correct, so your litter quality is deteriorating. So my thing is, instead of, you need to put some effort into fixing those dirty eggs coming in the first place, rather than how we're going to clean them when they come through. I see there's a question there about parasitic acid, and I have used that in the past, and there's a couple of things I would say. It's effective for cleaning. Unfortunately, it destroys your trolleys and any other metal that you have. The other thing that we found, because at the time we were doing a lot of breeders, and it changed. So in breeding, every different line you'll have a different color pen when you write on the eggs. Parasitic acid turned everything green. So all of a sudden your line security was a bit wobbly. But it's an effective cleaning agent, but it eats through metal. So it's not really, for me, it doesn't really work that well.
About the potassium permanganate that was used in comparison to formaldehyde?
Potassium permanganate, when you mix it,
using like when we get before formaldehyde or in replacement of formaldehyde. What do you think about that?
Well, potassium permanganate, I've only ever mixed with formaldehyde to get it to blow up, so yes, you get that very fast reaction, and it works well. I mean, but it's not terribly safe thing to do. You need to make sure that those granules are quite thick, because if you get the ones like powder, then it just blows up in your face, and I wouldn't recommend that.
A lot of people are still using formaldehyde and have some more questions coming about that. And you said, I mean, it works. We all know it works.
Yeah.
What are your thoughts on that? Is that something that everybody should just implement, or is that kind of necessary in times when other things aren't right? Or
no, I mean, you've still got Virusid on the market. That does very well. That's a good product to use. Like I say, formaldehyde, if it's used properly, the most times when I see that you have a problem with formaldehyde is the fact that your circulation in the fumigation room isn't correct. So what happens is when you extract, either they're not running the circulation fans, but when you walk in there, you can still smell it. But that's a problem with the system, not a problem with the fumigant. So it's one of those things. I remember, I think it was about the second day I got into this industry, and I was told that formaldehyde is going to be banned. And so like 32 years later, I'm still waiting.
And in some places it is. There are some places.
Yeah, there's certain areas
that it is. So I think even though people are still using it, I think everybody's like, okay, what can we?
But you need alternatives for sure. Yeah.
But
and I think the Virusid is a good alternative to that.
That would be a good alternative.
Yeah.
Okay. What about a peroxide? And I've seen people with dry hydrogen peroxide or even another peroxide infusion as a replacement to formaldehyde.
I've seen it, and it seems to work quite well. I haven't had hands-on experience with it, and I haven't tested it afterwards, but I don't see why it wouldn't.
If the application is correct and all that.
Yeah.
What would you see going in the future? And we have, particularly here in North America, we have a changing labor market. It seems like everybody's looking for people. Everybody's looking for people and can't ever get enough consistent people. How do you think that's going to affect our sanitation standards?
Well, I think we need to build it into the hatcheries in the first place, so that you build a sort of one-way system, so people can't sneak back. Or because it is, there's also, if we look at the way buildings are made, you've got cameras and AI that can actually identify where people are. You've got a lot of like RFID technology now as well, so you just, whatever they're wearing, it can be. I think actually here in Malaysia, there's the hospitals, every piece of equipment has an RFID tag sewn into it. And so they know where every piece is within the building. And that we could do in the hatchery quite easily. And if somebody's where they shouldn't be, it would already ping you. So there's a lot of tech available now, which we should be thinking about maybe we don't implement it now, but we should be thinking about how to implement that in the future.
Mhm. Yeah, I think there is some discussion on more of an internal type of thing, is what do we do for the whole unit, type of thing to protect it. What are your thoughts on using fogging, like a thermal fogging situation, using organic acids? I'm not exactly sure what they're talking about with organic acids, but what?
I don't know. Whenever I hear acid, I get scared, but I'm not sure. I wouldn't be able to give you a
Not sure.
I
No.
wouldn't know. No, so
Yeah, and
I
I'm not.
wouldn't.
That's why I asked you, because I'm not sure either. So,
No.
Okay.
It's probably
Well,
something we need to spend more time on, to be honest,
mhm,
as to look at all those alternatives for
absolutely.
fumigations, because right now we don't really know. We couldn't put them side by side, and that's what we should do, is a side by side shootout.
Hmm. Yeah, and but we do need to look at a lot of different options, because we might be forced to do things differently than we always have. So, but anyway, well, thank you very much for your presentation. Always got a lot of good.